Let me know if you could see my
Yeah.
window. Yep. Okay, perfect. Okay, so topic for today is element timing and Shadow DOM. My name is Amiya. I am a WebPerf engineer at Microsoft. I joined the working group a few months ago. This is my first TPAC. Today's topic, I want to revisit sort of an older issue that's been discussed in the past, but I just wanted to share some of my observations and pain points related to element timing when it's used in conjunction with Shadow DOM. So before element timing existed, web developers really had no direct way to observe when elements of their page were painted to the screen, and that's really important for measuring perceived performance as experienced by your end users. But web developers are they'll always look for workarounds, right? So there were hacky sort of approximations that existed and been used for a long time. So if you were trying to observe when an image is painted to the screen, you might use the resource timing API or a load handler that's on the image tag. The downsides with these approaches, they're not totally accurate. They're not measuring when the image actually paints to the screen. They're actually measuring when the network activity was over in the case of resource timing, or when the load handler fires, which probably doesn't coincide exactly with when that image actually shows up on the screen. If you had a text element, you might use some kind of inline script tag. The most common approach was sort of an after frame callback. One approach was to have an inline script marker, a perf marker that's scheduled inside a combination of a request animation frame plus set timeout. And there's some other flavors of this approach as well: request animation frame plus request animation frame, or request animation frame plus. There's some other approaches there that were used, and that would basically tell the browser to record a performance marker at the next frame, basically after the current frame has completed. So that approximates when a given chunk of markup has painted to the screen. The downsides with this, again, this is not totally accurate. This would tend to over-report the number as opposed to the prior cases where they would under-report. And there's also a bit of an observer effect, because just simply including a script tag inline in the page to do this instrumentation can actually change the actual rendering behavior of the browser. So the browser might induce paints given the existence of that script tag that may not have otherwise happened. So this could change the behavior of the page when you're just trying to observe it. And the element timing API was great because it fixed all of this. It added a declarative way for web developers to observe when specific elements had been painted to the screen. So that was a great step forward. And just to illustrate, I've built a couple of pages. So these pages look basically identical, and I've shared the links here. One page is just a really simple page, an H1, a paragraph, and an image that's really big, so that sort of forms a long pole. And the source is shared over here. So I have a performance observer that is just looking for element timing events, and it'll basically do a console log every time an element timing event is fired. And I have element timing set up for each of the tags. So there's an element timing for the H1 that just logs an H1 string. There's one for the P, and there's one for the IMG element as well. So each of these fires its own element timing event. And then I have the same page also implemented with Shadow DOM, where the image is actually implemented as a Shadow DOM image, as a Shadow DOM element, and the H1 and P tags are the same. And I've added an element timing attribute to the outer div, which contains the Shadow DOM but doesn't contain any additional content. And I also have an element timing attribute here, which is inside the shadow element. And what you'll see if you open these up is in the case of the no Shadow DOM page, you get these three events: the H1, the P, and the IMG. They all fire their own element timing events. And typically the IMG one is the last to arrive because it's an external image. It's pretty big. So that number is higher than these others. And over here, if you load up the page with the Shadow DOM, it will not fire element timing events, neither for the outer div nor for the IMG. So this is a limitation of if you're trying to implement a page that contains Shadow DOM elements, web components, you're not able to observe the performance of that page. Going back to the slides. And there have been prior discussions about this. This is not something that's new, but I just wanted to bring this discussion up again and hopefully move this forward, get it to a place where we can have this implemented. There have been some prior discussions. The gist of it is that the behavior is sort of by design, given that Shadow DOM is isolated from the rest of the page, so the rest of the page can't really observe what's going on in the Shadow DOM. But there was a case being made for an element being able to opt in to being observed. So if a web developer is writing a component using Shadow DOM, they should be able to opt in so that the parent page could still measure when that element showed up on the screen, for example. So what are the implications of this? As I mentioned, so Shadow DOM elements cannot use the element timing API, which is a bummer. We had this great new feature implemented, and now we're not able to use this. I know of one case where for MSN.com, they were moving from React to web components, and the React pages did use element timing successfully to measure when certain critical elements showed up on the page, and they had to take a step backwards. So they had to go back to using sort of the prior, more hacky techniques that I discussed earlier. Which was an unfortunate side effect of the migration to web components there. And the other case, I just ran web page test against those two pages that I built, and so LCP still does capture the Shadow DOM element. So it's kind of a mismatch between these two sort of approaches. So LCP is sort of a built-in approach where the browser just gives you this this metric, which it's sort of a one-size-fits-all approach to measuring the perceived visual performance of a page. And so LCP does capture that image. I can pull up the I don't have, okay, yeah, I have the links here. So in this case, this is let me pull up the page with no Shadow DOM first, and you can see the LCP is about 1.3 seconds, and it's clearly waiting for that big image to come down, which is the long pole in the waterfall. And so that the LCP is recorded as 1.3 seconds here. And the same is the case in for the page with Shadow DOM. So again, the LCP is 1.3 seconds here. So it seems like a bit of a mismatch between these two approaches, where if you're using the more declarative approach, you're missing out on the ability to measure specific components on the page. Although if you use the LCP approach, you are accounting for that performance. So I wish that element timing was able to handle this as well. So that's what I had to to present today. But happy to open it up for discussion.
Oh, thank you. Let me